All right, so we're just going to look at the last transformations we can do to a circular graph, and these ones make it easier. There are two of them. The first one is we're going to rearrange into y equals, and you start by moving the x squared across to the right hand side, and then you take the square root of both sides and you end up with plus or minus r squared minus x squared. All right, from here, you notice that there's a plus or minus, so this gives you a positive version or a negative version, and I'll show you what the versions are of. All right, it may not surprise you, but it might. The positive version is a semicircle, and the negative version is a semicircle also. So we have the top half of a semicircle, which is r squared minus, x squared, and the bottom half is negative r squared minus x squared. All right, so we have top half, bottom half when it's in y equals. Now, the other transformation we can do is to rearrange into x equals, and you go x squared equals r squared minus y squared. Take the square root of both sides, x equals plus or minus the square root of r squared minus y squared. Now, just like a sideways parabola, you may or may not be surprised to know that this gives you a right-hand side and a left-hand side. All right, so the right-hand side is the positive because those are positive x values. The left-hand side is the negative because those are negative x values. All right, notice that in those equations r squared stays the same as the radius, or it's still the radius, it's still written as r squared. So we'll put that to the side and we'll have a quick look at an example of a question like this. This one is about sketching this graph, and it's y equals minus 2 plus root 49 minus x minus 2 squared. So first of all, identify transformations or key features. That's r squared. This is h. And this, in case you don't know it, it's sitting out there by itself, which indicates that it's a k value or vertical translation. So we've got our horizontal translation of plus 2, we've got our vertical translation of minus 2, and our radius is 7. So we can do a quick sketch. We can put the center point at 2, negative 2, so 1, 2, 1, 2. So the center point is here. We have a radius of 7, so we can put the end points at 2 take away 7, so the end point is down here at minus 5, 2 plus 7, so the end point is up here at 9. And then the other thing we can do is do a quick sketch of the semicircle like so. All right, now the reason I drew it like that was because further inspection of the original function says here that it's a positive root 49 minus x minus 2. Going back up here to the two parts we looked at, it was y equals and positive. So this part here is the positive half of y equals. So if you ever see something like this, you can compare it to the originals and work out which part you're sketching. Now the only other thing left to do is to identify any, if there are, x-intercepts and y-intercepts, and you can see there are some of both. So we're going to solve for where x equals 0 and for where y equals 0, and then label the graph. So first of all, where x equals 0, we'll just plug in 0 in place of x. You're going to get minus 2 plus root 49 minus minus 2 squared equals minus 2 plus root 49 plus, nope, that's a minus 4. So if you're not quite sure there, minus 2 squared was positive 4, and then a minus stays there, so it's minus 4. So this is equal to minus 2 plus root 45. Notice that there's only one. There's a plus here, and that is it. And if you look at the graph, you can see there is only one y-intercept, and you can just label it as, I've simplified that in my head, root 45 is the same as 3 root 5. So that y-intercept there is minus 2 plus 3 root 5. All right, now it's got to find the x-intercepts, and I'll do that by allowing y to equal 0. So 0 equals minus 2 plus 49 minus x minus 2 squared. Move the 2 across, so 2 equals root 49 minus x minus 2 squared. Square both sides, end up with 4 equals 49 minus x minus 2 squared. Move the 49 across, so minus 45 equals minus x minus 2 squared. Divide by -1, 45 equals x minus 2 squared, square root both sides, plus or minus root 45 equals x minus 2. And you can see that there's plus or minus gives you two solutions, which we knew there had to be two x-intercepts from our sketch originally. Move the positive 2 across so it becomes 2 plus or minus root 45 equals x. So again, you can just label those. So this one out here is 2 plus 3 root 5, and this one out here is 2 minus 3 root 5. And those are the key features of your graph. You've just got to make sure you label everything you need to. This one was minus 5 comma minus 2, and this one was 9 comma minus 2. All right, so you've found the y-intercepts, x-intercept, center, endpoints you didn't really need to, but are key features anyway, so probably do find them. So to recap, you've got transformations of a circle can be divided into either top half and bottom half, positive r squared minus x squared, or negative, and then right half and left half by choosing either y equals or x equals. And that can be put to use when you're sketching graphs. You can identify changes that have occurred by looking at the form and comparing it to the forms you were given. I hope that makes sense.